Welcome back to day 4 of our Pandas series. Today's challenge, our marketing team at Panda Pizzas just expanded into branded merchandise. They want to pinpoint all the products that include shoe or shoes in the name so they can launch a targeted footwear campaign. They also have other conditions like focusing on items over $50 to match their premium brand image. Let's dive in to see how filtering and querying in Pandas makes this a breeze. Let's dive in. Now, before we get started, a quick side tip. You may have this question in your mind: how can a pizza shop launch branded merchandise? The answer is that many food brands have expanded into lifestyle merchandise to strengthen brand recognition and customer loyalty. That's why Panda Pizzas, also a fictional pizza brand, could justify selling shoes. Now back to Pandas. So these are the topics that we will be covering today. First, we'll talk about filtering data using numeric comparisons, okay? And then we'll also talk about how you can have multiple conditions both with and or. After that, we'll talk about string operations and regular expressions, okay? And finally, we'll talk about the query function. Let's get started. Hey there. So what's the scenario for today and what is the data context that we have so far? The scenario is that we have to identify all the products or the merge items with shoe in them. Also, management only wants to see the products which are of higher price than $50. When it comes to the data context, we have a data frame df underscore products. Okay, so you can see it looks like this: df underscore products. You have product ID, product name, category, cost, and price. Now, what we're going to do today with Pandas is going to help marketing, because finding items that match certain string patterns helps marketing to quickly identify which products to promote. Filtering by numeric values like price ensures we only target items that fit the brand's price range. Let's get started. To start with, let's try to filter out products in this particular data frame which have a price which is greater than $50. Remember, Boolean indexing is our friend in these type of scenarios. Let's see this in action. So I can say over here, premium items, let's call it premium items, is equal to df underscore products, and over here we are going to have a condition. Okay, so let's first write it out: df underscore products price. Okay, so notice I'm using bracket notation to access the price column, and we want a value for this greater than 50. Okay, so what this condition over here does is that it will return a Boolean series marking true for rows where the price is greater than $50. Okay, and otherwise it's going to be false. So it's going to be like at index 0, let's say it's false. What's the case over here? It's less than 50, right? So for 0 it will be false, for 1 it will be false, and let's say for 3 it will be true. So we are going to get such a Boolean series back, and then after we have that, we are going to only take the rows for which we have true, and those would be stored in premium items. So let's go ahead and see how premium items looks. Okay, so you can see we have all the rows where the price is greater than 50 in premium items over here. Now again, we are just doing filtering over here. Now you could also have multiple conditions, like, again, let me just copy this over here so that we can write it faster, and I'll have a new block over here. Now again, let me say I want products for which the price is greater than 50, which is what we have over here. Let me remove this. And let's also say that we want the category to be footwear. Okay, so again, notice we have category over here. Okay, so let's say we want the price to be greater than 50, which is what we have over here, and we want the category to be footwear. So what I can do is I can put this condition over here in a bracket, and then I can say and I can mention the second criteria, which is, let's say, df underscore products, and the category is what I want. The category should be equal to, let's say, footwear. Okay. So I hope we have that. Let's see. I hope we have that in the data frame. Anyway, we'll have to check that. So let's say it's there and we have our condition over here. Now let's go ahead and see how premium items looks like. So I'm going to have that over here. And you can see, yes, it's working. We have category as footwear and price is greater than 50. So we are just doing basic filtering at this point, and you can use and or similarly how you would be using it in typical coding. Okay. So you can use and or, and also remember parentheses are crucial for grouping. Okay. Now, again, why is this useful from a business angle? Marketing specifically wants premium footwear in this case, and with these conditions, we are already zeroing in on that subset. Let's now proceed and learn something more. All right. So, what we're going to learn now is about string operations and regular expressions. You may have heard about regex, okay, which stands for regular expressions. Now, we're just going to get ourselves introduced to this. You have many variations of it, and again, once you know what it is, then the details you can always figure it out based on what the exact scenario is with which you're dealing at a certain moment. So to get started, let's take a look at the .str.contains function. Now again, the context over here is that, let's say we want to filter out product names that have the exact word shoe or shoes. Okay, so that's the context. And again, we are going to get ourselves introduced to regex at this point. So over here, I can say shoe items is equal to df underscore products, and then over here we'll have to specify the condition which would return us the boolean series. Okay, so it's pretty similar to what we did over here. Okay, so we are going to get back a boolean series, but again, the difference is going to be in the way that we're going to write this condition. So let's first write it out and then let's discuss it. So over here I can say df underscore products at product name, which is what we have over here, and then you can say .str dot contains. Okay, and our aim is to identify products that start with shoe. Okay, so over here I can say shoes, and now I'll also have a question mark over here, and then I'll say regex is equal to true. All right. So again, high level, we know what's happening. We are going to get back a Boolean series where we have true in certain cases and false in certain other rows. And then finally, all the rows where we have true would be stored to shoe items. But what is it that we are writing over here? We are going to take a look at the column product name in the df underscore products data frame. So this is something that we are familiar with. We have used bracket notation to access this particular series. Remember, every column in a data frame is a series, and then we are saying that the value in those particular cells should contain shoes. Okay, so this much should be pretty straightforward, but this question mark over here is something that regex or regular expressions provides. Okay, so that's why we have said regex to equal true. Now if you did not have this, like if regex was false, then we would be searching for this exact string shoes along with a question mark. Okay, but because we have said regex is equal to true over here, what happens over here is that this last character, which is s, is optional, which means that you can have s occurring either 0 times or 1 time. Now, when s is occurring 0 times, the string would be shoe, and when s is occurring 1 time, the string would be shoes. So, in this way, using regex, we are able to search for products that either have shoe or shoes in the string or in the product name, which is the value in this particular column. Okay, so that is what we have done over here. So basically, we are just trying to match for shoe or shoes. Now let's go ahead and run this, and then probably maybe we'll also discuss a little bit more about what a regular expression is. So let's go ahead and run this, and let's also see how shoe items looks like after that. Oops. All right, so let's run this. And you can see that we have all the rows where the product name contains shoe or shoes. Okay, so you have all of these over here. Now again, if you had shoelace in some of the product name, that also would be coming over here, because we just want shoe or shoes to be there in the product name. Now again, coming back to regex or regular expressions. Now you can have a separate detailed video about regular expressions. It's a big topic in itself, but over here we first want to take a look at the high level things that are there in pandas. Okay. Now, regular expressions, what is it? Let's try to understand this a little bit more. Regular expressions or regex, which is what we have over here, are patterns used to match and manipulate text efficiently. Okay. So, in this case, we wanted to match shoe or shoes, or anything that has shoe or shoes, right? So, that's why we used regex is equal to true over here. Now, they are used commonly in string searching, validation, and text replacement. And do remember that you can use regex directly in pandas functions like .str.contains, which is what we have seen over here. And then if you may want to replace a string with something else, then you have .str.replace, and you can also use regex in the query function, which is something that we're going to see next in this video. Now, we have got ourselves introduced to regular expressions. Now, to get ourselves familiarized with regex a little bit more, let me quickly paste some code over here. So, you can see that we have this data over here, which is just a dictionary. You have email over here, and then you have a set of emails, right? So, that's what you have over here. And we have converted this dictionary into a data frame. We have seen that in day 1, or I think day 2, how you can convert a dictionary into a data frame. And then we are specifying a condition, which is what we're doing, so that we get back a Boolean series. And then wherever we have true, we will take those values and put it to gmail_df. Okay. And notice that the condition mentions that .str.contains, which is the same thing that we had over here. And then over here, we have the expression R. R indicates that we have to treat all of this as a string. So R stands for raw string in Python. And again, it's always a good practice to use raw strings in Python regex to avoid issues. Okay. So this is a raw string. And then the pattern that we're giving is @gmail.com. Okay. So anything that has gmail.com would be filtered out. And what we are doing over here is we are trying to find matches or emails that has and again, all of this is part of regex syntax, and you can go deeper into it. But over here, we want to get introduced to it, and we want to see how we can use regex in pandas. Okay. And over here, you have a slash, which is to escape the dot, since it's a special regex character. Okay. So in this way, you can get all the emails that have @gmail.com at the end. Now let's also go ahead and take a look at gmail_df, and let's run this. And you can see that yes, it's working. You're able to filter out and get the data where you only have @gmail.com at the end. Okay. So this was a quick detour, but again, we've got ourselves introduced to .str.contains, and we have also seen how you can use regex in pandas. Now let's move on to the next thing that we are going to cover in this video, which is .query. Now, the .query function is another way to filter data. Okay. It can feel more natural, especially for those who like SQL-like syntax. So let's go ahead and write an example. So let's say you only want premium shoes which have price greater than 50, and of course the product name should have either shoe or shoes in it. Okay. So the way that you can write this is you can say premium shoes query, and over here you have df_products dot query. Okay. And notice you're giving this condition over here. The first thing is that price has to be greater than 50, and product_name.str.contains shoes, and you have a question mark, regex equal to true. So this over here is something that we have seen previously. And again, the question mark is to indicate that S, which is the last character over here, can occur 0 or 1 time. And the reason for that is we want both shoe and shoes to be included. So this is how you can query something using the dot query function in Pandas. Premium shoes query looks like. So let's go ahead and run this, and you can see that it's working. We have price greater than 50 and the product name contains shoe or shoes. So again, the dot query function is just another way for querying data or filtering data. Now let's also see one more filtering of data where you're using an OR condition. So let me just quickly paste that over here. And you can see that over here, what we're doing is the condition over here is OR. Okay. We have seen previously a condition with AND. So over here we have OR, and the first condition over here says that the string, the product name should have shoe or shoes. And I've said regex is equal to true over here. And then we have product name contains slipper, and we have said regex is equal to false. So let's go ahead and run this and see how footwear variety looks like. And if there were any slippers in it, we would get that as well. Okay. So this is how you can implement an OR condition. And the last thing for today, let's also quickly discuss the .str.replace function. Let's say when you inspect data, you see that for some entry, instead of writing shoes, the person whoever made that entry wrote sh0es. Okay. So what you can do is you can find those data points and then you can replace that with shoes. So what I'm doing is I'm saying df underscore products, product name. So I'm accessing this series, okay, or that column, and then wherever the string is sh0es, that's going to be replaced with shoes, shoes. Okay. And then we are assigning that to df underscore products product name to this column over here, so that whatever change we are making over here gets assigned to this particular column. Okay. So this is how you can replace and make any corrections in the data if you do find such errors are there. And that's it for today. Quickly reviewing what all we discussed. Let's say we noticed some products had their names spelled incorrectly. We could use the .str.replace function to correct that, which is what we have seen over here. And then we also saw how we can filter out data. Like, let's take a look at that. So over here, we've seen how you can filter out products which have a price greater than $50. And we also saw how to use regex expressions with .str.contains to filter out products which have shoe or shoes in their product name. .head to check the output for seeing whether everything is fine, and we could share this with marketing. And that's a wrap for today. We have covered Boolean indexing with numeric comparisons, multiple conditions using AND and OR. We have seen dot contains and dot replace with string operations, and we have also talked about regular expressions for flexible matching, as well as the dot query method for a more SQL-like syntax. All of these help us zero in on exactly the products or rows we need. Marketing can now swiftly identify relevant items for targeted campaigns. No more manual searching through spreadsheets or guesswork. And that's it for day 4. If you found this useful, hit that like button and subscribe for more. Let's get ready to transform our data on day 5. See you then.